Section 1.8 is on perimeter, circumference, and area. So let's start with perimeter. The perimeter P of a polygon is the sum of the lengths of its sides. A polygon, remember, is a closed figure whose sides are made up of line segments. So any polygon, the perimeter, the distance around the outside, is the sum of the lengths of its sides. The perimeter of a circle is called the circumference, and I know you've all done circumference before. And the area of a polygon is the number of square units it encloses. The same actually holds true for a circle, a polygon, or a circle, or any other shape for that matter, is the number of square units that it encloses, the area. Okay, so let's look at some of these formulas. Common formulas for perimeter, circumference, and area. So write these down. Square. Perimeter is 4 times the length of the sides. The area is s squared, where each side has the same value. Rectangle, 2b plus 2h, or 2 times b plus h. And the area is b times h. Sometimes this is also written as length times width. Either one is fine. A triangle, the perimeter is the length of the 3 sides. So side A, B, and C. The area is 1/2 the base times the height. Now the base can be any one of these, but the height has to be perpendicular to the base. So that would be my height in this case. And a circle, the circumference is pi d, or 2 pi r. Since d equals 2r, these are equivalent expressions, and the area is pi r squared. These are all formulas you should have seen before, and these are all formulas I would expect you to know for a quiz or test. So let's apply some of this together. The garden club has a rectangular garden that measures 15 feet by 30 feet. They want to increase the garden area by planting a 3-foot border all the way around the current garden. So the first thing I would do in this kind of a situation is to draw a diagram. So the current garden is 15 by 30. They're going to extend that, and I know this is not proportional, that's okay, by adding 3 feet all the way around. So the first question is find the area of the new border. So area, and I just want the area of the border. First thing I have to do is find the new length of the sides. So if this was 30, let me change colors. If this was 30 and I add 3 feet on each end, my new length is going to be 36. If this was 15 and I add 3 feet to the top and the bottom of it, this is now 21. So I'm looking for the area that I've shaded in red. Not the entire thing and not the middle, but just the area shaded in red. So to me, the best way to find that is to find the entire area of the whole shape and then subtract the area of the middle. So the area of the new entire garden would be 21 times 36. So this would be a good thing for your calculator. That's 756. The area of the old garden, I'm going to label this A sub n. Anytime you use a subscript, that helps you keep track of what you're doing. The area of the old garden is 15 by 30, so that's going to be 450. And the area of just the border would be the area of the new garden, the whole thing, minus the area of the old garden. So 756 minus 450, that looks to me like 306. And that's going to be square feet because it's area. Okay? Let's do another one. Find the new perimeter. This one's easier. I've got my new dimensions, 21 by 36. So perimeter is 2 times 21 plus 2 times 36. So that's going to be 42 plus 72 which gives you 114 feet. The last question. If they want to create a circular pond in the middle of the garden that has a diameter of 5 feet, circular pond, diameter of 5, that's all the way across, what will be the area and circumference? Well, circumference is pi d, so that's easy. That's just 5 pi. The area is pi times r squared. My radius here is only 2.5, so 2.5 squared is 6.25, so 6.25 pi, and again this would be square feet and this would just be feet. So notice that I've left things in terms of pi. We'll talk about that a little bit in class, but for the moment that's the most accurate answer that you can give. Alright, let's look at some of this on a coordinate plane. So given the ordered pairs A, B, and C, so the first thing I want to do is plot those. 2, 3 is A, -1, 0 is B, and 2, -2 is C. So I'm going to go ahead and label those both with the letters and with the coordinates so that I can see everything in one place without having to look back and forth from the graph and maybe get my numbers mixed up. So the first thing is plot the points. I've already done that. Second thing, find the perimeter of the triangle. Okay, this forms a triangle and I need perimeter. Perimeter means I need distance. Now we just learned the distance formula. So the perimeter, the distance, and again I'm going to use some subscripts, of AB is the square root of x minus x, 2 minus a -1 squared, plus y minus y, 3 minus 0 squared. That's the square root of 3 squared plus 3 squared. That's the square root of 18. And I'm just going to leave it like that for now. My next distance, let's do BC, is the square root, again, x minus x, -2 minus 0, plus, oops, I did y first, sorry. Let's do x first. 2 minus a -1, and then -2 minus 0 squared. That's the square root of 3 squared plus -2 squared, and that's the square root of 9 plus 4, which is 13. And then the distance of AC, since they are perpendicular to each other, since they are on the same vertical line, I can just count the difference between my squares. So 1, 2, 3, 4, 5. That's 5 units. Whoops, sorry. So that one's just going to be 5. So the perimeter is the square root of 18 plus the square root of 13 plus 5. If you plug that in your calculator, that's approximately equal to 12.85 units. We don't have a particular value. Okay? My last question, and I should have done it down here, I'm sorry, is find the area. So the area is 1/2 the base times the height. So what height do we want to use? I'm going to change ink colors. If I did the height here, I'd have to know where the perpendicular point is. The same thing is if I use this height. So I'm going to use the height that is perpendicular to my vertical line. So if I use this right along the axis for my height, I can count that out as well. So 1/2 my base times my height. My base is AC. We already said that was 5 units. My height, since it's a horizontal line, I can count that, is 3 units. So that's 1/2 of 15, or 15 halves. If you want to change that to a decimal, 7.5, and that's square units. Okay? If you have questions on this, write it down in the margins, and we will get to it together. The last thing, Postulate 110, the area addition postulate. The area of a region is the sum of the areas of its non-overlapping parts. In other words, the area of this region can be found by breaking this into pieces, however you want. So your challenge for class is to come up with an area for this figure. Assume that all of these lines are at right angles to each other. Okay? And you should be able to find areas of several pieces of this and add them up to find the total area. So that's your challenge. I want that done before class time. Come in with a nice picture drawn and some good work shown, and we'll see how you did. That's it.